Okay, so chapter 3, factors and products. And there is, today's February 12th. There you go. So the first section in our book is 3.1, factors and multiples of whole numbers. Okay. Prime numbers. A number that can only be divided by 1 and itself. Okay, that's a prime number. Prime numbers are going to be very, very important to us in this unit. Okay. And did you know that any number that you can possibly think of can be made up of prime factors? Okay, so you think of any number, 6, I can get it by multiplying 2 and 3. You think of 12, I can go 2 times 2 times 3, right? So you'll see how that works. So prime numbers, some examples here, the first couple, right? 2, 3, 5, 7, 11, 13, 17, 19, 23, and there's an infinite number of prime factors. So you go dot, 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 because it never ends. Factors, numbers that are multiplied to obtain another number. So example, 2 times 3 is equal to 6. These are the factors. And this is the product, or the other number. And if I go a little bit fast, folks, I'm going to post this video. I just want to make sure that before the long weekend, we have this covered. Okay, example, 3 and 7 are factors of 21. So it's another example, just like I did here for you. Okay. And a note here, 21 is not a prime. It is a composite number. Okay. So any number that can be divided by other factors is a composite. So if you're not under the prime list, you're a composite. Okay. So 10, is that a prime? Wait a minute, I can go 2 times 5, right? I can go 2 times 5 to get 10, so 10 is a composite number, right? 12, I can go 2 times 6, so it has more than just itself and 1 as a factor, okay? So there you go. Prime factorization. This is going to be prime factorization. Make sure you get comfortable with that. Okay, that terminology is going to be used a lot. Now, it's writing a number as a product of all its prime factors. It's the product of all its prime factors. So example, I'm going to break this down to you, okay, one line at a time. So think of 12, for example. If you think of 12, right, you go 4 times 3, that would be probably most of you are going to be, yeah, 4 times 3 makes sense. This is just factorization. It's just a factorization. You've just come up with two factors that make up 12. But if you want to go prime factorization, you break down the 4, which you right, 4 is not in our list of prime factors. So we're going to go, hey, I can make 4 by going 2 times 2 and then times 3. This is prime factorization. Okay. You can also write this exact same thing. This is the expanded form. We can say, hey, 2 times 2 is the same thing as 2 squared. And then we can go times 3, right? This is called prime power factorization. And this one here is what we call the expanded form. So they're both technically prime factorization, but sometimes expanded is better than the short power version. You'll see sometimes we prefer one over the other, but they're both correct. Okay. I want to talk about divisibility rules. I haven't done that in the past, but divisibility rules are rules that will help you to see a number and be like, wait a minute, oh yeah, this is even, I can divide it by 2. Can this be divided by 3? I don't know. How do I check? Some of you probably learned how to find divisibility rules. I'm just going to give you a short, summarized version of that, okay? So here it is. And these are worth memorizing, okay? Divisibility rules, so just a couple. Last digit is even, so that's a question mark, right? Yes can be divided by 2 then, right? So 2 is a factor. And in a sense, that's what you've just determined. 2 is one of the factors of that number. Another one is add up digits, right? And then you can ask yourself two questions here, right? Sum divisible by 3, right? If the answer is yes, then number can be divided by 3. And I'll show you this later on, right? And then you add up the digits, and if you find that the sum is divisible by 9, then the whole number can be divided by 9. Okay? So adding up digits helps you to find if 9 or 3 is a factor. So Can I add this here? When you say that something can be divided by 3, then you're also saying that 3 is a factor. And if a number can be divided by 9, then you can also say that 9 is a factor. And this is the last divisibility rules. There are more, but yeah. 6. Okay, 6 is a tricky one. For 6, then this has to be true here and this has to be true. Right. So if you remember that, good, right? But you can navigate by just sticking to these ones without combining. You can navigate, but if you figure it out, good for you. Yeah. And I think the textbook will walk you through some of those, okay? And if the last digit, this one, you should all know this one. If the last digit is 0 or 5, right? Then 5 is a factor. Okay? Meaning the whole number can be divided by 5. And I'm sure that a lot of you or everybody knows that one. The reason why is you're not allowed to use a calculator. Okay? And so you need to know, let me do this. There you go. 0 or 5, that is, okay? Then 5 is a factor of that whole number. So I could give you examples, but I'm just going to do it on the fly as we go. I'm going to go through these ones here with you, okay? Um, when you're trying to break down a number, there is no right way of doing it. Like some of you will look at the prime factors and say, like, oh yeah, I look at this number, I know that 7 is a factor of that number. Some of you will be like, no, it's even, I'm going to start with 2. Sure, like it doesn't matter how you get there as long as you get there, and the examples will show you that. Okay, so write the prime factorization, and these are fun, of the following. These are fun, but you need to practice them because it's going to be very important for everything else we do, not just in this chapter, but in the chapter after, chapter 4. So we're going to write the prime factorization of 400. So let's call this A, our first example here. So what does that mean, Mr. Dirksen? Prime factorization, what does that mean? You want to break this number down so that you have it as a bunch of numbers being multiplied, and all of those numbers are going to have to be prime. Okay, so I'm going to look at this, and I look at it and I know that it's even, right? So I'm going to say, hey, this breaks down into 2 times 200. So you're making a factor tree. This is called a factor tree. And then I'm going to say, hey, I'm just going to keep going because I'm having fun with this, right? 2 times 100 gives me 200, right? So keep going. I'm having fun with it, so I'm going to go, you can either go 4 times 25, right? Or you can go 2 times 50. Are you following? Which one is right, Mr. Dirksen? There is no right way. You're just going to have, your tree will just look slightly different. So let's go 4 times 25. So just so you know, prime, prime, composite, composite. These are not prime yet. So you got to keep going, got to break them down. So we know that 4 is 2 times 2, all prime, right? So you're done here. You can't go further. The tree stops there. The roots are done. The 25, you can break that down into 5 times 5. Now if you look at the ends of the roots, right, they're all prime. Every single one of them is prime. You notice that? So We can circle them like this if you like. I'm not going to do that every time. But what have you just discovered? You have discovered that 400 can be written as 2 times 2 times 2 times 2. So I'm just going along the roots here, times 5 times 5. So this is the prime factorization of 400. And you can rewrite this as 2 to the power of 4 times 5 to the power of 2. Okay, and there it is. And if you don't believe me, right, just for, right, 2 to the power of 4 times 5 to the power of 2, that's 400. So voila, right, you've done it. So the key is that when you get to the end, you should have only prime. So what are prime, Mr. Dirksen? 2, 3, 5, 7, 11. That one is easy to remember, right? You're thinking of a Slurpee right now. So those are the couple, the ones you need to know and remember. Okay, let's keep going. B. So let's go a little bit bigger here. 2646. I'm moving to the middle because the tree kind of opens up this way, right? And I know some of you have learned, I don't know how do you call this, the bar method. Some teachers do like a straight line here, and they do it a slightly different way. If that's how you've learned it, you can stick with it. I understand that. Okay, I get it. Okay. Now, doing like always doing finding 2 first is a little bit more tedious, but what you can do is let's add up the digits, okay? Remember the 3 and the 9 rule? You got to add up the digits. So I'm just going to do on the side here, right? 2 plus 6 plus 4 plus 6. So you're literally adding up the digits. So this is 8 and 10, that's 18, right? And so you can, this is divisible, oops, divisible not only by 3, but also 9, right? Because 3 goes into it and 9 goes into it. So what that means is that you could start with 9 if you wanted to, right? And then divide this whole thing by 9 and then keep going. But I find, I don't know, I find that the I find that if you see that it's even here, I'm going to go with 2. It's easier for me to do that. So I'm going to go 2. And so what you do is you divide this whole thing by 2 to see what else is left, right? So you start, right, like 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into 4 2 times, 2 goes into 6 3 times. So you've now said, hey, this number breaks down into this. And this is already a prime, so you didn't need to worry about it. Is this even? No, it's not, right? So we're going to go 1 plus 3 is 4, 6, 9. So you can actually divide it by 3 or 9. But I'm going to go with 3 because then I know it's over for the 3. I don't need to break it down even further. So I'm going to divide, right? 13 divided by 3, that is 4. Carry over, right? This is 12 divided by 3, which is 4 as well. And then 3 divided by 3 is 1. So you've now broke that one down into 441. Let's do the check again. 4 and 4 is 8 plus 1 is 9. You can still divide by 3. Okay? So 3 goes into 4 ones. Carry over 1, right? So you have 14 left. 14 divided by 3 is 4. You get 12. and then the 2 carry over, so 21 divided by 3 is 7. Mr. Dirksen, I don't know what you just did there, right? So it's basically 441 divided by, right, divided by 3. So you can do it on the side if you need to, right? Goes in there once, subtract, bring down the 4, 3 goes in there 4 times. 4 times 3 is 12. Subtract, you get 2, bring down the 1. 3 goes into 21 7 times. 3 times 7. And then, so if you need to do this on the side, by all means do it. There's nothing wrong with it. And keep going. I'm going to do the check again. 1 and 4 is 5, plus 7 is 12, so you can still divide by 3. 3 goes into 14 4 times, then there's 27 left, goes in there 9 times. So you need to practice this, okay? It's 49, 7 times 7, and those are both prime. So you're now done, okay? This is how I do it. I always try to have a prime on the left, and I keep going to the right. But it doesn't matter. If you wanted to divide this one by 9, right, it would have been 9 times whatever else. So then you have to keep breaking 9 down, which is 3 times 3. And you start and you do the same thing with the other side. And so 2646 is really 2 times 3 times 3 times 3 times 7 times 7. Right, so you just go down, and then 2646 is also 2 times 3 to the power of 3 times 7 to the power of 2. So this is the prime factorization of that number. And what I want to say here is always write factors in ascending order. So for example, if you wanted to go, hey, it's going to be 3 times 2 times 3, like mixing them up, we don't like that. We want, and you will see why later on, you want them in ascending order. So the smallest first, and find all the 2's that you have gathered, all the 3's and all the 7's and whatever else comes after that. Okay. I'm thinking I'm going to give you one more. Let's try 3300. Okay. 3300. So I see that it's even. I'm going to go with 2. Right. So then you can say 2 goes in the 3 ones. That means that there's 13 left. 2 goes into 13 6 times. And there's 1 left, right? 10 goes in there 5 times. And you have to add a 0 to it. Okay. And again, if you do this divided by 2, right? You can go 1, goes in there once, bring down to 13, goes in there 6 times, that's 12. Bring down to 10, that's 5. And then so you need to make sure you add that 0 here. Okay, the last one goes there, so that's 1650. This is still even. And I can actually say 2 goes into 16 8 times. You're done there. 2 goes into 50, or sorry, 2 goes into 5 2 times. Then there's 10 left, which is 5. Okay. Next, I know that this ends in a 5, but it also, if you go 8 plus 2, that's 10, plus 5 is 15, right? So what's that divisible by? 3, right? So you have a choice. Divide by 5, divide by 3. I'm going to divide it by 5. 5 goes into 8 one time. There's 3 left over, so that means that there's 32. 5 goes into 32 6 times. Then there's 25 left over, which is 165. I still see that it ends in 5, so I'm going to go with 5. 5 goes into 16 3 times. There's 1 left over, meaning that there's 15 here. It goes in there 3 times. 33, you should recognize that 3 times 11, once you get to the end, you should recognize that 3 times 11 are the 2 prime factors for it. So 3300, and this is where you need to practice, okay? I'm performing, I have my notes all done, right? Yours may look different, okay? I actually would like to encourage you to cover this up, try it again, see if you get there a different way. I actually encourage you to do that, okay? 3300 is 2 times 2 times 5, oh, not times 5, times 3 in ascending order, right? Then times 5, and another 5, and the 11 there. So you're not going to only have 2, 3, 5s. It can go up to 11, 13. It keeps going. So you have to practice, right? So 3300 in power notation would be 2 squared times 3 times 5 squared times 11. Okay. I'm not going to get to the word problems. That's okay. How's this? Is this okay for a Friday? Some of you are like, I just can't wait till the weekend, right? And same here, same here. You need to practice, okay? If this is kind of challenging you, that is okay, but you need to practice, okay? Greatest common factors. We call that a GCF. The GCF of 2 or more numbers is the largest factor the numbers have in common. If you want to think of it a different way, it's the biggest number that goes into all of those numbers that you're finding the GCF for. Okay, that's what the GCF is. Okay, example, GCF of 36 and 24, factors of 36. This might be a little overwhelming, but 1 goes into it, 2 goes into it, 3 goes into it, 4, 6, 9, 12, 18 goes into it. And obviously don't forget about itself, right? So 1 and itself is always there. Don't forget that. Some students they just don't think that that's the case, right? But it is. Factors of 24, and I've arranged them already, right? But I'm thinking 1 goes in there, 2 goes in there, 3 goes in there, 4, 6, 8, 12, and itself. And notice that you can do the check, right? 3 for 36, 3 and 6 is 9, meaning that both 3 and 9 go into it. You do the check here, 2 and 4 is 6, 3 goes into it, but 9 doesn't. Okay? So the greatest common factor that they both share in common, the biggest number that goes into both of them is 12. This is a visual representation of that. 12 is the GCF of 36 and 24. This is the long way of doing this. You do not want to be doing it this way moving forward. What is the GCF of 138 and 198? Step 1. Write the prime factorization of each number. So this could be the case. It could ask you the GCF for 2, 3, 4, as many numbers as you can think of. The steps stay the same. Okay, so that's the first step. So let's do that. 138, we're going to break that down. I know that's even, so 2, 69. I add them up, 6 and 9 is 15. So I know that 3 goes into it. 3 goes into that 23 times, and 23 happens to be a prime. So you're done. So 198, we're going to do the same thing. It's even, goes in there 99 times. I know that 99 is 9 times 11, so sometimes that's nice. 11 is already a prime. 9 needs to be broken down into 3 times 3 still. Step 2. Write both in expanded form. Both have to be written in expanded form, not the power form. So for example, you have 138 here, and 138 is 2 times 3 times 23. I'm going by this here. 198 is 2 in ascending order, okay? 2 times 3 times 3 times 11. Circle the common prime factors, including repeats. This is going to be it. We're going to end with this, okay? So 1 to 1. So the 2 goes with this 2. They have that in common. This 3 goes with that 3. There's nothing else that you can pair up with. There's no 3 up here that goes with that 3. So you're done. Okay? There's no pair left. So the GCF is step 3, I guess. The GCF is found by multiplying the 2. So they share 2 in common. So 2 times the next one they share is 3. So the GCF for these two numbers is 6. right? I'm going to stop there. So I'm going to tell you what the homework is. So that booklet, remember, you got a small booklet. I'm going to cover this up once, okay? It looks like this. You all got it, right? If you don't, I'll get it to you. Yeah. And so there, I want you to do page 134, which basically goes through the divisibility rules. So you're going to do 1, and then so just question 1. And then there's page 140. I'm going to ask you to do 4, 5, 6, 8. Can I think you can handle that, and that's basically practicing what we did today, okay? And then I'm going to give you more because we're going to cover more on